All right, let's do 2.1. Some of the questions that were on that one. First one was number 2. If a wrench is dropped, it follows this equation and it says estimate the instantaneous speed. So if this is the distance, it'll be the change in distance over the change in time. And we're supposed to do it at 3. Probably the easiest way to get a good approximation would be to, let's type in the equation into y equals, so that's 4.9x squared. Okay, then I'm going to quit. The instantaneous, that's going to be the slope of the tangent line, but we'll do something really close to this tangent line. We're going to figure out the slope, which means y2 minus y1 over x2 minus x1. And I'm going to do it this way. I'm going to do parenthesis. I've typed that into y1, so I'm going to do vars, y variables, y1 evaluated at something really close to 3, but just before it. How about 2.999? That's 1,000th of a second before 3. So it'll figure out the distance there. Oh, I should do it just after because I'm supposed to do y2 minus y1. So I'm going to do 3.001, that's 1,000th of a second later, minus y1, parenthesis 2.999, oops, too many nines. So that's 1,000th of a second before. All of that, close parenthesis, for the numerator, divided by the difference of those two numbers, which would be 3.001 minus 2.999. Close parenthesis. And I get an estimation for the instantaneous being 229.4 meters. Let's see. Yeah, meters. This is in meters per second. That would be the instantaneous speed. Change in distance over change in time. And I'm going to do this. Now it says find the average for this equation. Well, that's a line. And so the average rate of change is going to be just the slope, 4. And the instantaneous at 2 is also going to be 4. But I'm going to show you that. I'm just going to go to y1 and put in the equation 4x minus 9. And then I'm going to use what I just did, but I'm going to now put in stuff between, I got to go from 2 to 5. So I'm going to put in 5.000 and then 2.000. I'm leaving the zeros in there for a reason. And then I'm going to put 5.000 minus 2.000. And it tells me, ooh, what did I do wrong? Parentheses should tell me 4. What did I mess up here? Oh, I put too many zeros and I wiped out a parenthesis right there. Okay, so that's the end of y2 and then end of the numerator. Now I press enter and I get 4. Okay, and now I want to do the instantaneous at 2, so I want to go just a little bit after 2 minus a little bit before 2. So I'm going to bring back that equation and I'm going to go up here. A little bit after 2, 2.001 minus y at 2. Right, a little bit before 2, which would be 1.999. 2.001 minus 1.999. Enter. 4. It's always going to be 4. It's a line. No matter where I find the slope on it, it's going to be 4. Okay, number 7, it says, what's the rate of change if you make a deposit? And this shows you how much the total amount is after a certain amount of time. Well, the units of rate of change is going to be the change in dollars, so it's going to be dollars over the amount of time, and the time here is in years. Dollars per year. It says figure out the average rate of change between 0 and 0.5. So I'm just going to go to Y1 and put in the equation. 100 parenthesis 1.08 close parenthesis to the X. Then I'm going to quit, and I'm going to bring back that equation, the slope equation, y2 minus y1 over x2 minus x1. And I want to do the rate of change from 0 to 0.5. So I'm going to put in 0.500 and then 0, 0.000, and on the bottom I'm going to put 0.500 minus 0.000, and it says the average rate of change is 7.84. Dollars per year. Okay. Then I'm supposed to do it between 0 and 1. So bring the equation back, and now I'm going to do, my big number is 1.000 and 1.000. Enter. Still doing slope, and I get the average rate of change from 0 to 1 is $8 per year, which is exactly the interest rate, 8% of $100. And what's the instantaneous at 0.5? So now I want to look just slightly before 0.5 and slightly after 0.5 to get a line, the secant line that's really close to the slope there. So I'm going to bring it back and go slightly after 0.5, which is 0.5001 minus 0.5, a little bit before, 499, and that's slightly before. And put those same numbers down here. 0.5001. I got too many. I lost my parenthesis here. One close parenthesis. 5.01 minus 4.99. Close parenthesis. And enter. Oop. Got something wrong here. And 0.501 minus 0.499. I don't see my, oh, I see what it is. 4, got an extra decimal, delete that one. There we go, enter. 7.998. That's my estimate. 7.998 is my estimate for the instantaneous. Halfway through. It's almost 8. Early on it's less, later it's probably more, making an average of 8 over the whole interval, 0 to 1. But at 5 it's close to the average of 8. Okay, so I'm continue doing basically the same thing, only now I have a graph to look at. The average rate of change at P, which they said was right here, the 2010, and this is off a graph, and this is some population or whatever. So the average rate of change at, or the rate of change at here would be the tangent line, which they drew here for us, and it goes from 35 to about 55. So I'm going to go 55 minus 35 over from 08 to 12, that's 2012, minus 2008. So that's 20 divided by 4 years, or 5 per year. 5, what was this one? 9. Population, I think. Gotta look it up in the book here, just to remind myself. This was a percentage of the Chilean population that uses the internet. So 5%. That's the rate of change there. Now, it asks, is the rate of change increasing or decreasing as time goes by? Well, it looks like the rate of change, or the slope, is getting steeper, so it must be increasing as time passes. And what is the average rate of change from 2008 to 2012? So I'd do from the slope between the two ends. So I would do how much it was at 2012, which was, I gotta look back, about 60,000, 60%, minus the beginning, which was about 40%, over 2012 minus 2008, which is 4 years, and again that's 20 over the 4 years, or about 5% per year. Now, it wasn't going at 5% at the beginning, it was going more than 5% at the end. It increased as time went by. So at 2012, is the rate of change greater than the average? Yes, it is. It's steeper here than the average was. The average, which is this right through the two endpoints, and the slope here is steeper than the average slope. Okay? It is greater. Is greater. Okay, 13. Now we're just doing instantaneous for different graphs here. So I can go right back to my calculator and put into the equation. So I'm going to clear, and I have 1 divided by parenthesis x plus 2. And then to find it at 2, I'll just go a little bit before, a little bit after. The point, just a little bit after minus a little bit before. So I'm going to go back to my home screen, second enter, and I'm going to put something just past 2, which should be 2.001 minus the y value at just before 2, which is 1.999, and then that's 2.001 minus 1.999, and enter, and I get an average rate of change on this one of about negative 0.06, negative 0.0625. I hope you're understanding what I'm doing here. I'm just taking 2 points close to the point that they want me, one a little bit before and after, and figuring out the slope between the lines. That's what I'm doing. So now I have to do it between near 0 for e to the x. So I go to y to there, clear that, and put in e to the x. And then I'm going to go quit, bring back the equation, and I got to go either side of 0. So I'm going to go up here and do just past 0. So that would be 0.001, and just before 0, which is negative 0.999, negative 0.001. That's just a little bit before 0. And same here, 0 and minus a negative 0.999, and minus 0.001. So that difference should be 0.002 on the bottom, and the top is going to be whatever the calculator figures out for e to the 0.001 minus e to the negative 0.001. And we get a slope of approximately 1, or really close to 1, 1.000. So that's the estimated instantaneous slope at 0, 1. Later in calculus, later in this course, you'll find out it is exactly 1. Okay, tangent inverse of x. So just go to y equal and type in tangent inverse of x. Close parenthesis. Quit and now do it near pi over 4. Yeah, so this is going to be a little bit tricky because I don't know what pi over 4 is exactly. So what am I going to do? Well, I'm going to go up here, bring that back. I got to go a little bit past pi over 4, so I'm going to go pi over pi divided by 4, a little bit past it, plus insert 0.001. So that's a little bit past pi over 4, minus pi divided by 4, a little bit before it would be minus 0.0, oops, second insert 0.01. So I want pi over 4 plus 0.001, so 1,000th past it, minus 1,000th before it, and down here it's going to be the difference between 1,000th and 1,000th, which is 2,000ths. I can leave it like this, or I can put all that pi over 4 stuff. The pi over 4's cancel, and it becomes same as what I got there, so I press enter, and I find that the slope is really big, about negative 497.99, about almost negative 500. And what does tangent inverse look like at pi over 4? Is this mode? Yeah, it's in radians. So let's just graph this thing and see. There's the tangent inverse, and at pi over 4, let's see, window trig, zoom 7 for zoom trig, and at pi over 4 is right there, and it's not that big, so there's something wrong. Let me see if I messed up a parenthesis again. Second quit. Okay, y1 of this plus a little bit minus y1 of this minus a little bit. Oop, yep, got to have a close the y1 and close the numerator. Lost a parenthesis. So my answer should be, second insert that other parenthesis, should be about 2. I thought that was awfully big. That's why I looked at the graph. It's about 2. Okay, that's 2.1.